Lesson 80, Calculating Frequency Distributions. So this first slide is lots of vocab for you. Make sure you get this stuff in your notes. Okay. Discrete events have a finite number of events. That means a specific number of events. A compound event consists of two or more simple events. So that would be, for example, something we've done in the past. A compound event would be flipping a coin and rolling a die, or rolling a die and flipping a coin. Those are two simple events that you can put together for a compound event. A frequency distribution shows the number of observations falling into several ranges of data values. Okay, so make sure you have those in your notes. It says a sailboat owner kept track of the weather for 3 months. Make a bar graph that shows the frequency distribution of the data. Find the experimental probability of each outcome. So what we're going to do is we're going to use this table to create a bar graph. It said bar graph, right? Yes. Okay, so what we have is we have the weather and the number of days. So this is our X over here. These are our X values. These are our Y values. So I have a graph. This is number of days down here, and then this one is the weather. So the types of weather are sun and wind. So sun and wind. The next one is no sun, wind. So no sun and wind. The next one is sun and no wind. And the last one is no sun and no wind. Okay, see my abbreviations are very nice. All right, so our days range from 8 to 42. So I'm going to go by 5s up the side for my y-axis. So I have 5, 10, 15, 20, 25, 30, 35, 40, and 45. So we'll go 10, 20, 30, 40. So the number of days with sun and wind, the frequency that happened was 42 times. There are 42 days that this happened. It's going to be about there. Then the number of days that there was no sun and wind was 24. So it's going to be right under that 25 marker. So I'm going to go down just a little. Okay, the next one is sun and no wind. There were 18 days like that, so just a little under the 20 mark. And the last one was no sun and no wind, which was 8 days. Maybe about there. Pretend that this is all nice and straight. Same number of space between. Okay, so this is my frequency distribution table that I've made. And the last thing it wants us to do is find the experimental probability. Well, we can do that right here next to these. First thing that I need to do is find the total number of days that he did his observations. So these two together would give me 50. And these two together would give me 42. So it's a total of 92 days. Okay. So this one is going to be 42 out of 92, 24 out of 92, 18 out of 92, and 8 out of 92. And this I would show as the probability of sun and wind. This is the probability of no sun and wind. Okay, all the way through. And then we need to reduce those. You can do that on your own, and I expect you to. So if you're at home, use your calculator on your cell phone. If you're at school, grab a calculator, punch those in, and reduce them, please. Example 2 says the names of 2 students will be drawn at random from a 4-person group that include Joe, Ed, Dee, and Kim. So on A, it says to make a table to show the possible outcomes in this experiment. So we're trying to put them in groups of 2 or in pairs. So the first one would be if I had Joe and Joe. Well, I can't have Joe and Joe in the same group because Joe can't be in one group twice. Same with Ed and Ed, Dee and Dee, Kim and Kim. So now we can go through and fill these out. We have Ed and Joe, Dee and Joe, Kim and Joe. Then we have Joe and Ed, D and Ed, Kim and Ed, Joe and D, Ed and D, Kim and D, Joe and Kim, Ed and Kim, D and Kim. Okay. Oh my gosh. Oh no, that's fine. I thought I put the wrong name. Alright, so we have made the table. Now it wants us to find the theoretical probability of each possible outcome. So we're just going to start with the first one, which is Ed and Joe. So the probability of getting Ed and Joe in the same group, and it doesn't matter the order as long as it's those people. So Ed and Joe could be in the same group right here or right here. So that is 2 out of a total of 3, 6, 9, 12 outcomes. So I have 2 out of 12, which gives me 1/6. The next probability is going to be the next group, which is D and Joe. I don't know why it's changing colors and making random lines. D and Joe could be together here or here. So that would be 2, again, out of 12, which gives me 1/6. And as you can imagine, if we continue through these, we are going to get 1/6 for each of them because they're all equally as likely. For our last example, it says, suppose that 20 cards are put in a box for drawing. There are 12 cards with hearts, 5 with circles, 2 with squares, and 1 with a star. It says, make a bar graph to represent the frequency distribution of all possible outcomes. So there are 20 cards total. So I'm going to make my graph. And I know the first cards have hearts, then circles, then squares, and stars. So I have hearts, circles, squares, and stars. And I'm going to go 2, 4, 6, 8, 10, 12, 14. Okay, and this is the number of cards. These are the symbols on the card. Okay, so hearts, there were 12 cards with hearts. So for the hearts, I'm going to go up to 12, make my bar, bring it down. For circles, there were 5 with circles, so it's going to be right between the 4 and the 6. About there. Oh, pretend that's straight. They should be nice and straight. 2 with squares. And 1 with a star. Okay, so this is my graph to show my frequency distribution. And then it wants me to find the theoretical probability of each. So we said that there were 12 here, there were 5 here, 2 here, and 1 here. So my total, I have 12 plus 5. I'm going to add all these together. Okay, that's 17, 18, 19, 20, which they told us in the word problem. So I have, for the probability of getting a heart, 12 out of 20. Okay, which will reduce. So we're going to reduce by 4 on top and bottom, so I get 3/5. The probability of getting a circle was 5 out of 20, which is 1/4. The probability of getting a square was 2 out of 20, 20, that's a 2, which reduces to 1/10. And finally, the probability of getting a star, oh my goodness, what the heck, how about that, star, 1 out of 20, which doesn't reduce. So that's my final answer. That is all that I have for you. So hopefully you found this to be a fairly easy lesson, and I will see you in class tomorrow. I hope that you've taken good notes and that you have a good night.